Hey there, thanks for tuning in. I'm Jimmy Nisbet, Director of Business Development at RapidCanvas, and I'm excited to walk you through how our Auto AI platform can be a game changer for your business data strategy. At RapidCanvas, we've assembled an exceptional team of data science and AI experts from around the globe. This has enabled us to build a platform that allows anyone to activate the power of AI on their data. Through simple prompts and configurations, you can use Gen AI on your data to get specific answers, generate comprehensive reports, and even build sophisticated models for complex problems. In this demo, we're going to take a look at some credit card transaction data to look at some of the trends and patterns indicating whether a transaction is likely to be fraudulent or not with AI. Now, I'm not a trained data scientist, far from it, but I'll be showing you how RapidCanvas makes it easy for anyone to build AI models. So first, let's take a look at the data. Here we have the transaction data. We've got a lot of different fields. Looks like some of the fields are a little bit messy in terms of the data that's populating in here. You can see this one has some unnecessary words popping up in it. I also have like a date of birth column that I need to clean up and get an actual age group so I can actually use that field. And so there's a little bit of work that needs to happen before we start building the model. So this is the fraud test data, and the first thing I did was I removed that fraud underscore from the beginning of each merchant name and created this new data set. So you can see once I entered this prompt on this data set, it gave me a new data set, this auto-generated one, and the merchant name no longer has the fraud underscore at the start. So that's good. Then I wanted to insert another column that categorizes which industry the job was in, keeping it high level as possible. And then I gave it some categories for it to use and populate, because a lot of the categories that they were, or the job descriptions that they previously had were kind of all over the place. So I wanted to clean that up a little bit so I could actually use it from a data perspective. And so that's what it gave me. It gave me this column at the very end here with healthcare and other kind of marked for any of those job categories. Then, like I said, I wanted to do a age column based on the date of birth column. And so I asked it to generate that based on the December 2024 date. And so it gave me age for each one of the buyers based on that. And then lastly, I wanted to create another column based on the city population to kind of categorize how big of a city the person lives in. And that way I kind of defined it by anything under 10,000 is a small town, anything between 10,000 and 400,000 is suburban, and then anything between 400,000 and above is a city. And so maybe kind of a rough categorization, but that's what gave me this prep data. So now I have the data ready to build a model. So let's go back to the canvas, and this is where that prepped data comes in. And then I wanted to start actually building a model to predict whether a transaction is going to be fraudulent or not based on all these different attributes that we have at our disposal. And so I created a binary classification. You can see where this is where the configuration comes into play. So I just chose is fraud as the target column, and then a binary classification as the problem type. And then I ran this. And then once that job finished running, it takes about 5 minutes or so, but it's actually doing, a week's work of data science work because it's testing a lot of different methods. Here we have the model insights. The feature importance chart basically tells you all the different fields that are useful in identifying if a transaction is fraudulent or not. So as you can see, the transaction amount being higher was oftentimes an indicator of the transaction potentially being fraudulent as well. So these are all good indicators of whether a transaction was going to be fraudulent or not. And then the confusion matrix, this shows how accurate the model was. So I was actually able to build a pretty accurate model in this short amount of time with relatively high precision and recall as well. So precision being the accuracy of when I say something is bad, it being bad, and then recall being out of all bad, how much did the model catch? And so relatively high performance. Maybe there's some additional improvement that we can ask about and get some insights from RapidCanvas's AI guide on how we can make this a better model. So I asked it, is this a good model or not? and it gave me this output, and the model was highly accurate, so that's a good sign. Both precision and recall are high, indicating a good balance between false positives and false negatives. Overall, the model performs well, but the suitability depends on the specific context and requirements of your application. So then I wanted to give it some more background on what my priorities are. So I said if my priority is to say yes to as many customers as possible and minimize false positives while still catching a good percentage of the fraud, is this a good model? How could it get better? And then it gave me this output right here when I asked that prompt, and some pretty good advice. Let's look at the Ask AI features of RapidCanvas and how we can ask questions of the data and get a response or a report or a graph generated. So first, this is the newest data set from the model that I have that shows the prediction of probability of them being fraudulent or not. Now, I wanted to ask RapidCanvas to graph the transaction count over time with a 30-day small moving average. So there we go. You can see some cyclicality. It looks like maybe a weekly or monthly cyclicality here. And then we've got a peak during the holiday season, which makes sense, pretty typical for credit card transactions. And then I wanted to graph a trend line for the count of fraud transactions over time. So we can see here some cyclicality in terms of the peaks during certain times of year, but it doesn't seem like there's a spike during the holidays, which is interesting in this transaction data set. But you can see kind of that chart generated over time, so that's helpful. And then I wanted to ask what the average age of a fraudster is relative to the global average. And so you can see actually the average fraudster is about 2 years older than the global average, which is very interesting. Then I asked for a heat map of the US where the fraud is coming from. So it gave me this and showed that New York has the highest fraud count, and Pennsylvania and Texas seem to be close behind, with the Midwest and California also being kind of high areas for fraud. So then I asked graph the percentage of fraud across the 10 highest categories, and then I got this output. So this is percentage out of all the transactions being fraudulent. So it looks like grocery point of sale was a high category, shopping being on the internet was a high category, and then shopping point of sale was much lower, but also still a high category relative to the others. And then I asked to graph the percentage of fraud across the top 10 highest job categories. So then I wanted to look at the column that I had made for city type and whether there's a pattern to be seen there in terms of the fraud percentage. And it seems like small town and suburban were slightly higher than city, which is interesting, but it's not super big difference. About 9% from city to small town, and so like 36% for suburban. Then I wanted to graph the fraud percentage by age, and this was interesting. So it looks like for some reason in this data set, if you're age 22, you're 100% committing fraud. And then also there's a peak at age 100 with 3.5% of those centenarians committing fraud, which is interesting. And then I wanted to graph fraud percentage by the day of the week. So let's see if there's a pattern there. And it looks like Wednesday, Thursday, Friday seem to be the most popular, with Saturday and Sunday kind of being in the next category. Monday and Tuesday, the least active for fraudsters. So that's pretty interesting data that we were able to just get by asking a couple questions and getting those AI generated responses. So that wraps up my demo for today. I hope you found it interesting how we can use our platform at RapidCanvas to solve a lot of different data challenges. You can see there's a lot of other categories that this solution can be applied to, and happy to talk through any particular business challenges that you've come across that you'd like our help on. We have AI experts that we can call upon and loop in to see how we can activate AI on any of your data sets. So please feel free to reach out to me via LinkedIn at James Nisbet, and I'll also include a link below so that you can reach out to me directly if you're interested in discussing how RapidCanvas can be applied to your business. So thanks for your time, and hope you have a great rest of your day.